Now I know you want to get started developing in Hedera and setting up your environment, but before that we still need to cover some core concepts in Hedera. By the end of this video you will be able to describe core concepts like consensus, mirror nodes, the Hbar token, state and history. Consensus and mirror nodes. The Hedera network is powered by nodes that ensure the security, scalability, and reliability of the distributed ledger. Node operators are responsible for running the node, maintaining uptime, and participating in consensus. The Hedera network consists of two types of nodes: consensus nodes and mirror nodes. Consensus nodes are a type of node in the Hedera network that participate in consensus process. Consensus nodes receive transactions, contribute to the Hashgraph consensus, and store the public ledger's latest state. Consensus nodes are currently permissioned and operated by the Hedera Governing Council. This means that only selected entities can be consensus nodes. Mirror nodes. Hedera mirror nodes are a type of node in the Hedera and the public network that replicate the ledger in real time without participating in the consensus process. They are a read-only node that provide access to the verifiable data in the public ledger. Although mirror nodes do not participate in the Hashgraph consensus, they receive ledger information from consensus nodes. Developers can communicate with mirror nodes through the Hedera mainnet, testnet, and previewnet REST APIs. The mirror node will give the developers access to ledger data. Mirror nodes can provide additional functionality such as indexing the ledger data, making it easier to search and query. This functionality can be useful for applications that need to perform complex queries on the ledger data, such as for analytics purposes or reporting tools. Hbar token. Hbar is the native energy efficient cryptocurrency of the public Hedera network. There are two main functions that the Hbar token plays in the Hedera network. 1. Network fuel, and 2. Network protection. Hbar is used by developers to pay for the network services such as transferring Hbar, minting fungible and non-fungible tokens, interacting with smart contracts, logging data, etc. Essentially, every transaction that occurs in the network will require an amount of Hbar to be used as payment fees to compensate validator nodes for their bandwidth, computation resources, and storage. Network protection. Since there is a proof-of-stake network, staking Hbar to nodes improves the security of the network. When Hbar is staked to network nodes, they have weighted voting on consensus for validating transactions. Weighted voting makes it expensive and therefore difficult for a bad actor to maliciously affect consensus, as the bad actor would have to own and stake over 1/3 of the network's total supply of Hbar. State and history. State machines are mechanisms that are used to manage the state of the ledger and ensure that transactions are processed in a consistent manner and update the ledger. They are also replicated across multiple nodes so that the nodes are able to maintain a consistent state of the ledger. Transactions are two different data structures with different properties. The state represents the current values of all the assets and the accounts on the network. State is mutable, which means it can be updated as new transactions are processed and applied to the ledger. The history of transactions represents a record of all the transactions that have been submitted to the network and applied to the ledger. It is seen as immutable and irreversible, contrary to state. There are three functions performed by a node. 1. Contribute to consensus. 2. Persist history of transactions. And 3. Persist state. But nodes cannot optimally perform all three roles because of their limited resources, so they make choices regarding which function to prioritize. Mainnet nodes. For Hedera, mainnet nodes contributing to consensus and persisting state are the priorities. The Hashgraph, which carries with it all the transactions that change the state, continuously removes all transactions information after it has been assigned a place in a consensus order. Mainnet consensus nodes can safely delete older portions of the Hashgraph, as they can be confident that the transactions contained in those portions have been applied to the state of the ledger and are not subject to change because of the algorithm delivers finality. Once a transaction has been assigned a timestamp, ordered, and applied to the state, there is no chance that it will be reversed. Consequently, there is no need to keep historical transactions. To prevent such historical transactions from filling up the node storage, consensus nodes delete historical transactions. Mirror nodes. We learned that the mainnet nodes delete historical transactions in a bid to save storage storage space. However, there is a need to preserve history. For example, an auditor might want to review the transaction history or trace the flow activity of the network. This is where the mirror nodes come in. Their priorities are to persist history of transactions and persist state. They can choose whether to store all history, no history, or possibly only a fraction of the history. Mirror nodes also store information that allows them to prove that their history is correct, even for some kind of partial histories. So a malicious mirror node is unable to lie about what is storing. Overall, a client seeking a transaction from the past would query through the mirror node for the record of that transaction, as the burden of storing history is taken by mirror nodes and not mainnet nodes. The latter can be optimized for more fundamental role of consensus and state storage. Let's go through a summary of some of the points covered. There are two types of nodes in the Hedera network: consensus nodes and mirror nodes. Consensus nodes are full nodes that actively participate in consensus process. Mirror nodes are nodes that store a copy of the network's transaction history and provide access to the data. They do not participate in the consensus process. Hbar is the native cryptocurrency of the Hedera network. It is used to pay for transaction fees and network services. State and history in Hedera. There is a main difference between these two concepts. This is reflected in the different functions that the mainnet nodes and mirror nodes play. I hope this video has been helpful in getting you started with programming on Hedera Hashgraph. If you have any further questions, you can contact me through x.com or in the comments below. Thank you for watching.